Hello, everyone. My name is Lorelai Boyd, and I'm a decision intelligence developer at Gray Decision Intelligence. I received my bachelor's degree in science and technology studies from Cornell University, so I'm really excited to jump into computational social science, which is a more targeted program emerging with the rise of social media. Our world is immersed in social media. Social media is ubiquitous and an increasingly important part of our everyday lives. Over 5.2 billion people worldwide use social media. A typical user spends about 2 hours and 19 minutes on social media every day. And in total, the world spends about 12 billion hours a day on social media. The most popular platforms include Facebook, YouTube, WhatsApp, Instagram, and WeChat. This widespread use generates massive amounts of data and influences behavior in ways we're still only beginning to understand. The first way of which would be through communication and social interaction. It makes it easier than ever to stay in touch. It offers diverse ways to communicate, like text and images and video calls to live streams. And it shifts social norms so that online interactions are now influencing offline behavior. It also influences the way we consume and share information. Now, through the democratization of information, social media allows for everyone to share information and perspectives, particularly bypassing traditional gatekeepers like mass media, but it also brings along echo chambers and filter bubbles, as well as the spread of misinformation, which leads into the next point, political and social engagement. Through the mobilization and activism, social media has been able to organize protests, raise awareness of social issues, and mobilize political action. It was used heavily during the Arab Spring, where platforms like Facebook and Twitter, now X, were instrumental in facilitating communication and organizing protests among activists across the Middle East and North Africa. They allowed citizens to bypass state-controlled media and share information about government corruption and human rights abuses, galvanizing widespread dissent and ultimately contributing to the overthrow of several authoritarian regimes. Again, on the other hand, it brings along political polarization and the spread of propaganda and disinformation, social media. Social media also influences the way we work and learn. We can now network and recruit via sites like LinkedIn. We can upskill through YouTube videos and tutorials, and we can engage in group discussions that have a kind of social media flavor online through forum posts for school and work. Social media also influences our purchasing patterns and sources, where now it's shifting consumer behavior to be through targeted advertising and influencer and brand ambassador marketing. Social media also influences our self-perception and identity, where people are often presenting idealized versions of themselves online, and we're engaging in a lot of social comparison and validation seeking online through likes and comments and followers. Finally, social media influences our mental and emotional well-being. Studies have linked excessive social media use to increased anxiety and depression and loneliness, as well as just the fear of missing out. Social media also brings about addiction and compulsive behavior, as well as decreased attention spans. So we see that social media influences our behavior. It also influences our relationships. Social media is built on and builds new relationships and connections between individuals and groups. Social media users connect with other users, forming embedded relationships. And as social media usage grows, our relationships in person and online with others are increasingly intertwined with and shaped by these online platforms. This means that our interactions, friendships, and even romantic relationships are often mediated through likes, comments, shares, and online profiles. There are 3 key components included in this, which would be the first of which would be profiles and networks. Users create profiles on platforms like Facebook and Instagram or Twitter, sharing information about themselves. This acts as their online identity and a starting point for connections. Users connect by sending friend requests, following accounts, or joining groups based on shared interests, hobbies, or causes. The second key component would be content sharing and interaction. Users share and interact with various content, including text and videos and links. This content is displayed to their network, fostering a shared sense of experience and interest. And finally, the third key component would be algorithms and feeds. With personalized content, social media platforms use algorithms to curate what users see in their feeds. These algorithms consider factors like connections, interests, past interactions to show relevant content, reinforcing connections with like-minded individuals. Algorithms also play a role in amplifying content, making certain posts go viral and reach a wider audience beyond a user's immediate network. This can lead to forming new connections based on shared interests and experiences. Understanding social media's influence on human behavior and relationships is driving a demand for an emerging field of study in academia. and this would be computational social science. Computational social science is an interdisciplinary field that uses computational tools to study social phenomena. It sits at the intersection of computer science and social sciences. The explosion of social media generates enormous amounts of data, and now modern computational methods can enable us to analyze these data sets in ways we couldn't before. We can analyze the content and also the relationships between users using graph data science and graph analytics. Researchers are gleaning insights into social and cultural behaviors driven by social media. They also hope to be able to predict future behaviors and address potential societal issues. There are 4 key goals: to analyze large-scale social media data, to model and predict social behavior, to understand the impact of technology on society, and to address social issues like polarization and misinformation. So, one example of how CSS is helping us understand the behaviors influenced by social media would be from the summers of 2019-2020, when Australia experienced catastrophic bushfires, burning over 24 million hectares, roughly the size of Oregon, killing 33 people and displacing or killing nearly 3 billion animals. The bushfires attracted a lot of public attention and generated a lot of data on social media. Researchers use computational social science to analyze 9,000 tweets to see how social media influenced public perception around climate change. They tracked keywords and hashtags about the bushfires to analyze discourse and perceptions on causality, blame, urgency, and prevention. And here's what they found. They were connecting the dots, so discussions increasingly linked the bushfires to climate change, raising awareness and driving engagement with the issue. There's a focus on accountability, where users actively called out those deemed responsible for the fires, including climate change denying politicians. And there was increased support for climate change. Despite some misinformation, the bushfires led to a surge in support for climate action on Twitter. So the demand for computational social scientists is beginning to grow. We found over 500 jobs with computational social science in the job title or description in our job postings database. A few examples are shown here on the screen, but graduates trained in computational social science can work in many other roles requiring CSS skills and training, such as data scientist, data analyst, social media analyst and researcher, research scientist, policy analyst, and user experience researcher. Some potential employers include social media and tech companies, nonprofit organizations like the Environmental Defense Fund, government agencies like the National Archives, Library of Congress, United Nations, defense agencies and contractors like the DoD and CIA, hospitals and healthcare, startups, and so on. And you can prepare for these careers with specialized degree programs in CSS. We are starting to see these being launched at the undergraduate and graduate levels, both with computer science and social science departments. So here are 2 examples. The first of which would be a BS in Computational Social Science from the University of Pittsburgh. It's offered by the School of Computing and Information. The curriculum combines social science fundamentals with data mining, machine learning, network analysis, and social science research methods. The major teaches students to use computational tools to analyze large data sets, model social phenomena, and use technology to research and address issues like inequality, political violence, and cybersecurity. It prepares students for careers in data analysis, research, and technology. The second example would be from University of California, San Diego, an MS in Computational Social Science. This was a master's program launched in fall 2022, but they also offer a PhD in CSS and a CSS minor. It's offered by a School of Social Sciences, and the program director is a linguistics professor. It targets students, including social science undergraduates seeking more knowledge in quantitative methods. So there are no formal math or computer programming prerequisites for the program. Instead, there's a 1-year program that begins with a 10-week boot camp designed to provide those foundational skills needed in statistics, linear algebra, calculus, and computer programming. So this is a relatively new program launched in fall 2022, and at maturity, the target program size is 35 students. The program is STEM qualified. And that is computational social science. Thank you.